We're going to do some demonstrations with conservation momentum. What we have here are two carts. This is cart 2, put on the track, about in the center of the track. It's going to be stationary. This is what we call cart 1. Both cart 1 and cart 2 have about the same mass. We're going to have these carts collide. And notice, these carts have two ends. Notice these are actually magnetic bumpers where they collide and they don't touch, but they repel each other. That way, there's very little contact between the carts when we collide them. But they also have another side. If I turn around this way, they'll collide and they'll stick together. With the magnets, they have Velcro bumpers. The magnets are not repelling them. But we're going to use the magnetic bumpers first. That way, they do not stick together. And we're going to have cart 1 moving, and cart 2 is going to be stationary. Let's see what that collision looks like. If cart 1 is going to be moving at a constant speed, they collide. Let's see what happens when they collide. You can kind of pause the video, make a prediction of what you think is going to happen after they collide, what's going to happen to the motion of cart 2, what's going to happen to the motion of cart 1. Remember, the masses are about the same. Cart 1 is moving, cart 2 is stationary. Let's see what happens. Notice, cart 2 went off about the same speed that cart 1 had initially, and cart 1 stopped, like cart 2 was before the collision took place. Now we're going to change this a little bit. We're going to add mass to cart 1. So now cart 1 is going to be about twice as massive as cart 2. We'll have them move about the same speed, and let's see what happens with that collision. Move cart 2 a little bit closer this way. Move about the same speed. Notice what happens. Notice cart 2 moves off with a velocity, and cart 1 keeps moving, but a slower velocity than what it had when it collided, before it collided. All right, we're going to change this again. Now what we're going to do, we're going to have the same carts. So I'm going to turn this around so that the Velcro bumpers, when they collide, they stick together like this. So we're going to have this collision take place. I'm going to have cart 1 move about the same speed that it had before. They're going to collide, they're going to stick together. You can pause the video, make a prediction. What do you think is going to happen when they collide and stick together? Is it going to be the same as it was before? What's going to be different about it? So here we go. Cart 1 is going to move. They're going to stick together. Notice they stick together, but they move off with a slower velocity than what they had, than what cart 1 had before the collision took place. All right, I'm going to change this again just a little bit. I'm going to add mass to cart 1, and they're going to collide again, and notice what happens. They collide, they stick together, and they move off slower than the velocity of cart 1. So now, let's change this a little more significantly. This cart has a plunger, so when I compress it, what will happen is when I press this little lever, the plunger expands. It has a little spring in here that adds energy to the system, so to speak. So now, I'm going to have them, so they're not touching, just close enough. Notice neither one is moving, so their momentum is 0, because mass times velocity is 0. This one has no momentum. Cart 2 has no momentum. Cart 1 has no momentum. I'm going to take this mass, I'm going to kind of flip this switch so the spring goes, and notice what happened. Both of them move with about the same velocity, but in opposite directions. All right, now let's take a look at another little demonstration of conservation of momentum and other things. This is what we call Newton's cradle. These are 5 spheres suspended, and they're suspended from the same height, so their centers are about lined up exactly, pretty close. It's not perfect, but pretty close. Now what I'm going to do, I'm going to take one of these spheres and pull it back. And you can kind of, if you've seen this before, you kind of have an idea what's going to happen, but make a prediction what's going to happen. When I drop this sphere from here, it's going to collide with these spheres, what's going to happen when it collides? Make a prediction, pause the video if you want to think about it. So let's take a look and see what happens. Notice one sphere comes off the other side with the same speed that the initial sphere had when it collided with the other 4. Now, we're going to do this a little different. We're going to take 2 spheres. Now I'll make a prediction of what you think is going to happen. 2 spheres are going to collide with those 3 and see what happens. Notice 2 spheres, the same mass of the 2 spheres before the collision, and the same velocity of the 2 spheres before the collision occurred. Now, what if we do 3 spheres? Make a prediction. What do you think is going to happen? 3 spheres go off, just like 3 spheres collided. They go off with the same velocity as the spheres had the velocity before the collision. Now, what if we do 4? Do all 4 of these. 4 of them go off. 1 of them stays down, just like it was. So 4 spheres collide with this one, and 4 spheres go off with about the same velocity as this 4 spheres had when it collided with that one. Now, this is a real complicated one. What if we have all 5 of them? Ooh, that's interesting. All right. Now, what if we do this? What if I take 2 spheres here and 1 sphere here? I'm going to try and drop them at the same time. Notice what happens. All these collisions follow what we call the law of conservation of momentum. We're going to do, your lecture notes will refer back to these. and explain why some of these happen as we go through the conservation momentum part of this chapter.